We started out this unit by talking about the importance of being algorithmically efficient by using indexes to resolve our queries. Now the next level of optimization is that we want those indexes to be in memory. Because if our index is not in memory, if our index is on disk, and if we're using almost all of it, then we're going to find that the performance is severely impacted, even though algorithmically it's much faster than, let's say, traversing the entire collection to get the answer. It still isn't going to be super fast if we have to go to disk to access our index. So there's a question, and we're going to talk more about this in the rest of the unit, about working set and how do we keep the most important parts of the data in memory. Well, even more important than keeping the data in memory is going to be keeping the index in memory. So the first question you might have is, how big is an index? Let's go back and look at this students collection that I created earlier. And if you recall, it has 10 million student records in it. So if we look at that collection, we can get its stats. And you can see that this is db.student.stats, and you can see that the average object in this is 232 bytes, and that overall this thing is using almost 3 gigabytes on disk. And we may not have a computer with 3 gigabytes of memory, but we might have a computer that's big enough to hold our index. So the next question is, well, how big is the index? And the answer is that if we run the command total index size, db.student's total index size, we will find out the size of the indexes on disk. And the answer is that our index, and we only have one index in this collection, if I recall. Well, I'm actually not sure about that. I'll check in a second. Our indexes are 543 megabytes. 543 megabytes, and now let's look at how many indexes are on this thing. Yeah, there's only one index that we added, which is this index of student ID. So overall, 543 megabytes of space spent on indexes. And if we're curious about how much of that is spent on the underscore ID one, I guess what we can do is we'll just drop the index that we created and run it together and find out. This is interesting. I don't know the answer. So I'm just going to remove the index on student ID. And we drop the index, and now we can see it's gone. And let's get our index size. And it dropped by not quite about half to 292 megabytes. So you can see that it looks like for every index that we add to this collection, we have to have over 200 megabytes of available memory if we want to keep all the indexes in memory, or at least the ones we're going to use. And this is important to keep in mind when you're designing your system. Think about, well, how large is my collection going to be, and how large is my index going to be? That's kind of a system administrator topic, database administrator topic, but it's good as a developer to just keep it in mind and realize that indexes are not entirely free, that you're going to want to keep them in memory and they can get kind of large, and that they are the single most important determining factor in terms of whether or not you get good performance from a query, whether or not those are in memory. All right, it's time for a quiz. Is it more important that your index or your data fit into memory? Check 1.